All right, so now we're going to talk about the binomial theorem. So the binomial theorem this is a theorem that is used to expand any power of a binomial expression, and the theorem is written as follows. And I'm going to give you a heads up. At first, it might just look like maybe it looks like, I don't know, Mandarin or something, or some other language. Let's write it down, and then we'll kind of talk about it, and we'll use the previous example to kind of help back up what on earth we are trying to point out here. So here, suppose we had a binomial x plus y to the exponent of n. So here we don't really know, we don't know what the exponent is. It's just some random variable n. And so what we're going to do is we're going to create a general statement to expand any binomial, expression. So to start, we have n, choose 0, times it by x to the power of n, times y to the 0. Now I'm going to explain this a little bit. So n choose 0, this one we can relate back to the Pascal's triangle, or even to the example above. Here we had the exponent of 7, so it'd be 7 choose 0, and there's only one way to choose 7. So here our coefficient there was 1. And so that goes the same along here. Your first coefficient for that first term is always 1. Then we have x to the n. Here x was a, and our exponent was 7. So we have a to the 7 times b, which was y. So b to the 0. So that's just 1. Then our second term would be n, choose 1, times it by x to the n minus 1, times it by y to the 1. So notice how we're going in that decreasing pattern for x values. So n to n minus 1. And then for y values, those exponents will increase by 1. So we go from 0 to 1. So then let's refer back to our previous example. So here we had 7 choose 1. And if we change it into factorials, that is 7 factorial divided by 6 factorial times 1 factorial. We know that when it's one number and the denominator is 1 factorial less, that is just equal to this number n here, so that is equal to 7. And so there we have it. So we have n choose 1, and then we have x to the exponent of 1 less, so from 7 to 6. And here our b value increased by 1, so we went from 0 to 1. So that's the same pattern here. Then our next one, if you guys can take a guess, this would be n choose 2 times it by x to the n minus 2. So it's 1 less from the second term, times it by y squared. All right. So once again, we can bring that back to our attention here. So notice our a exponents, they decrease by 1 every single time, and our b exponents increase by 1 every single time. So that is where we're starting to see this binomial theorem. Then we can add, and we don't know what n is, so this could keep going and going and going up until we get to the end. So our last two terms of, say, some random binomial would be, the second term would be n choose n minus 1, so it's one term away from n, times it by, this one here will be x to the power of 1, times y to the n minus 1. So notice here, those here are the same there. Then our last term will be n choose n. So this is when we're getting up to that last value there. Then that's going to be x to the 0. So we're going to get down to, it's going to decrease by 1. So we get x to the 0 times it by y to the power of n. Okay? So that this here is a general form of basically any binomial. We can rewrite it in this sort of way. So I kind of explained already how each one of these terms work. And so essentially our Pascal's triangle is just a different form, or we can use Pascal's triangle as an application for the binomial theorem. So as long as we know that Pascal's triangle, we can use this to simplify, and we don't have to do all of that work. So you know how you would normally multiply, say, x plus y to the power of n. you would start off by x plus y times x plus y times x plus y, and you would keep doing that n amount of times. So then you would work with your first two brackets. You get this big, probably quadratic form. Then we'd multiply that result with our next bracket, and so on and so on. So that can become a lot of tedious work, and I'm going to apologize. The binomial theorem itself is pretty tedious, but it's not as bad as actually expanding each bracket individually. That is a lot of work. This binomial theorem will be a little bit of work as well, but it's not as much as going the old way that we used to know. So if this still isn't quite making a bit of a sense, let's look at an example. So here we're going to use the binomial theorem to expand 3a minus 4b all to the exponent of 5. So we have 3a minus 4b to the exponent of 5. Here your x is equal to 3a, and your y value, and we want this to include that negative because normally it's x plus y, so that means that we're going to include this negative into our y value, so it'll be negative 4b, and n is equal to 5. So if we're going to just use just the binomial theorem, we're not going to include Pascal's triangle. We can always double check our coefficients using Pascal's triangle, but we'll just use the binomial theorem for now. So what we'll have is, so our first term will be n, which is 5. So we'll have 5, choose 0, times that by x, which was 3a, to the power of, that'd be n, so that'd be to the power of 5. Then times that by b, or I guess y, which is negative 4b, to the power of 0. Then our second term will be 5, choose 1, times it by 3a to the exponent of 4, times it by negative 4b to the exponent of 1. Then we'll have 5, choose 2, times it by 3a cubed, times it by negative 4b. Sorry, I'm running out of room there. And that one there will be squared. I'm going to write over here now. Then we're going to add 5, choose 3, times it by 3a to the power of 2, so it's going to decrease by 1, times that by negative 4b, and we're going to increase this one, so it'll be cubed, plus 5, choose 4, times that by 3a to the power of 1, times negative 4b to the power of 4. And our last one there, plus 5, choose 5, times it by 3a to the power of 0. If you don't mind, I'm running out of room there, but we know that 3a to the power of 0, anything to the power of 0 is just 1. So we'll just say times that by 1. Times that by negative 4b to the exponent of 5. So sorry, that right there, negative 4b to the exponent of 5. Then what we're going to do is we're going to simplify this. So here we have 5, choose 0. If you guys want to, you can put this into your calculators, or if we know that 5, choose 0, whenever we have choose 0, that is always 1. So that'll be 1 times that by 3a to the power of 5. So we'll apply this fifth power to each of those terms, so it'll be 3 to the power of 5. Times it by a to the power of 5, and negative 4b to the power of 0 is just 1. Then we're going to add 5, choose 1. If we want to write that out, that is 5 factorial. Divide that by 5 minus 1, so it'll be 4 factorial, times it by r, so that's 1 factorial. Then we have 3 to the power of 4, times that by a to the 4, and then times that by negative 4b, plus we have 5, choose 2, so that's 5 factorial over 3 factorial, 2 factorial, times that by 3 cubed, a cubed, times that by negative 4b squared, or I guess negative 4 squared times b squared, plus, then we'll go on to our second line here. So plus 5 factorial, divide that by 2 factorial, 3 factorial. So notice how these are essentially the same thing. So we should end up with the same coefficient there. And then we'll have 3 squared, a squared, times it by negative 4 cubed, b cubed, plus 5 choose 4. So it'll be 5 factorial over 1 factorial times 4 factorial. 3 to the power of 1 is just 3. A to the power of 1 is just a. Times that by negative 4 to the power of 4. And b to the power of 4. Then plus 5 choose 5. We should know that one. There's only one way to choose 5 from 5 objects. So that one there is just 1. Times that by, that was 3a to the power of 0. So we know that that is 1. And last we have 4 to the power of 5. B to the power of 5. And I'm going to keep writing down here. Hopefully you guys have some more room. Remember, I have giant monster writing. So I'm just going to continue down here. We're not going to be including any writing here, so if you do need to use the bottom of this page, you guys are more than welcome. So now what we're going to do is we're going to simplify this. So here we have 1 times 3 to the power of 5. And that one there is 243 a to the 5. And actually, if you guys want to, even before this step, you guys can put through your factorials and solve that. Find those coefficients before we start playing around with this, with these values out here, because here a had a number along with it, so it's going to end up changing those coefficients. So if you guys want to, find out what each of these factorials are, and see if it matches the coefficients that we saw in our Pascal's triangle. So remember, it'll be in the 5 plus 1, which is the 6th row. It should match up those values. Okay, so just note here that this 3, because it was attached to a, that's going to mess up those values a bit. Okay. Anyway, so keeping on with the question here, we're going to add, or in this case, we're going to subtract. We have a negative 4 here, and there's no exponent to help get rid of it. So it'll be 5 factorial divided by 4 factorial, which if you guys remember, it's just n. So it'll be 5 times 3 to the power of 4 times negative 4. If you want to, you guys can do this in little steps. If you don't mind, I'm going to do this all into one, so I'll talk it through with you guys. So this here is equal to 5 times 3 to the power of 4 times that by negative 4. So what we end up with there is negative 1,620. Then we get a to the 4 times that by b. Then we have 5 factorial divided by 3 factorial, 2 factorial. If you guys put that into your calculators, if you guys can figure that one out, we'll have this value times it by 3 cubed times it by negative 4. And sorry, this negative 4 here is squared, so this one's going to be a positive value. This squaring of the negative 4 will cancel out that negative. And what we'll have is 4,320 times that by a cubed, b squared. Then we're going to subtract. So kind of notice how it's going in this pattern. We have positive, negative, and it all has to do with those exponents. So then we have negative. It'll be 5 factorial divided by 2 factorial, 3 factorial. So this here will be the same coefficient, but instead we have 3 squared, whereas before it was 3 cubed. So it'll be this number times 3 squared times negative 4 cubed. So remember, because it's cubed, it'll be a negative number. And if you guys put that into your calculators, we will end up with negative 5,760 a squared b cubed. Now, to finish off this question, there is only 2 more terms left. I want you guys to do that one and then go on to video number 3.